8. Good. So you take 360, divide that by 8. Let's roll 45. So you have 45 on the outside. You all right with that? If you have 45 on the outside, what do you have on the inside? 135. Good. Now, 135 is that entire angle. What do you have to do with it? Cut it in half. Yeah. It bisects. Very good. So what's half of 135? Good. Now, here's where I'm going to suggest that you guys do something a little bit extra. Just draw the triangle you have. Right now, you have a triangle with a 7 for a hypotenuse and a 67.5 for there. You need to solve for your opposite, and you need to solve for your adjacent using the hypotenuse. What trig function works with opposites? Sine. Well, you were right, tangents work with opposites, but what trig function works with opposites, knowing in hypotenuse? Sine. And which one works with adjacents in hypotenuse? Cosine. So when you have a radius given to you, you need to just use 2 trig functions. Whereas when we had either the side or the apothem, you only had to use 1. So it's just one extra little step. So we have the sine of 67.5 is that opposite over 7. Cosine of 67.5 is the adjacent over 7. Once again, what do? How do you untrig it? Or how do you trig this? Let's sum it up. Notice, and Mrs. Thrower and I were talking about this earlier today, all of the steps that we're doing right now, guys, are the steps of everything we've done so far this year. There really isn't anything new except for that term, apothem. Everything else is the same. This is just a boatload of review. Okay. When you type that in the calculator, 7 times the sine of 67.5, what do you get with 2 decimals, please? 6.47? Thank you. When I do 7 cosine of 67.5, what do we get? 268? Thank you, sir. So now we have to think about where those values go. We go back to our diagram. That's why this stuff is so visual. That's why it's so important to draw that little 3-sided figure so you can fill in the blanks so that way you know which one's your apothem, which one is that portion of the side, and so on and so on and so on. So our 647 is our opposite, which means it's my apothem. That 268 was just this portion here, which means this portion is, and then your side length would have to be 268 plus 268. Cosine. We did that cosine plus for that one. So when you double that, you get what, 574? Sorry, 536. I was making sure you were paying attention. How many sides are in an octagon? 8. Now we know all of our parts. We know that we have an apothem. We have 8 sides of 536. So 1/2 of 8 times 5.36 times our apothem, 6.47. And there's all the info you need.
If you don't like that fraction, you can go ahead and multiply 8 times 5.36 times 6.47, take the whole thing, divide it by 2.
Or type in 0.5 times 8 times this times that. Any one of those works. Yes, ma'am. What? The 536? Remember, because what happens is that first right triangle we find from the radius is just one portion of the whole side. Because you can only get this part first, you have to double it to get the whole thing. And then I just rewrite that on that other portion, because then I know that I have 8 of these whole sides. And that's why I write that as perfect. very visual. It's just like this. You should see me going into this stuff. I'm like nuts. Kids are saying that, like, you really like trig. Visual. You can draw pictures, you can do this. It's great. Okay. You try this one. Say we have a decagon with a radius of 8. Find the area. Take a minute and go. My kids are like, you think Jeez. Let's see, radius. Decagon has how many sides? So if it has 10 sides, it makes your outside angle 36. So if your outside angle is 36, your interior is, half of it is 72. Good, good. Sounds so far so good. So we have the tangent of 72 will be your opposite. Not tangent, I'm sorry. Sine. Good morning. And then your cosine. So 8 sine 72. This is my opposite adjacent. And then 8 cosine. Buttons and buttons and buttons. What'd you get for your opposite? 764? 761? Thank you. Adjacent, what'd you get? 247? Okay. So that means that this little section is 2.47, which means the other little section is 2.47, which means the entire side length would be 4.94. Now, put it all together. We know that your answer is going to be equal because this 761 is your alpha. So we have 1/2 10 sides of 4.94 times the alpha of 7.61. What'd you get? 178.4? Sounds good. I don't know. I'll believe you. Something.
I got 180.7.
So, like I said, let's double check. You had all those values? Let's see here. 0.5 times 10 times 4.94 times 7.61. 187,967. I don't know. It depends on you. You might have pushed the button. Oh, that's the exact again. 4. Here's the deal. You have it all written down exactly what I would have for myself. I would probably would have looked at it and see how you got that. I probably would have figured it out with the others. So you didn't do anything wrong. Your thumb was just bad thumbs.
Mine is just I did a 49.44 times 7.
Oh, you did the 10 times that right away, and that's fine because you're rounded a little earlier, and well, actually you rounded better than I rounded because you did your 10 times that with more decimal stuff. So your answer is actually technically a little bit cleaner than mine would have been. But that's the whole idea that with these things you're going to get a bunch of range of answers. Everybody's probably within one. I mean, that's kind of what we're hoping to be. And if you're 12 away, we know something went wrong. But yeah. So really the only other weird thing that happens with these things, to be honest with you guys, is what happens if we ask, let's see how well I can do this. It's not bad. What if I ask you to find the area of the shaded region?
You have
Huh.
to find it.
All right. Well, what do we do here? Well, what's the large shape? It's a circle. What's the shape that's cut out of it? It's an octagon, isn't it? It's an 8-sided thing. Right. So that means, in my mind, in order to find the area of a shaded region like this, we have to find the area of a circle, and then we'd have to subtract the area of the regular polygon. So when I see shaded region, I initially write down, well, what are the formulas of things that I need to know? Well, circle, that's just pi r squared. The regular polygon would be a 1/2 perimeter apothem. Well, we need to figure out what information is being given to us. So let's say we have our center. Here's our apothem. It's not even the center. Perpendicular to the sides. So I change colors. Let's say in this case we have an apothem. I don't think we've done one with an apothem in a while. So we have an apothem of 5. If I have an apothem of 5, that means I need to figure out my radius, and I also have to figure out my side lengths to get my perimeter, don't I? I'm sorry, what? The apothem? No, remember the apothem. The apothem is the segment that's drawn from the center to the side. The radius goes to the vertex. The vertex is what lies on the circle. So your radius is always going to be larger than your apothem. Okay? The radius will always be from a segment that comes from the center in a circle. The radius will always be the longest length. This side portion has an area below it, which means that there's still room to go past it to be able to draw a radius in. So when I'm looking at that, we still do the same setup. Notice that you have an octagon. It still does all this. And if you recall, we did an octagon problem, what, 10 minutes ago, I think? We knew that the outside angle was 45, the inside angle was 135. Half of the 135 was. So then you have to figure out what the radius is, knowing the apothem. Figure out that little section is, knowing the apothem. So if I'm looking at my trig setups here, when I get going to it, what trig function will I use if I know that 5 is my opposite, r is my hypotenuse, sine? So I know sine of 67.5 is 5 over r for the radius. This is where we do the good old-fashioned exchange-o, change-o. To get that value of x, that little portion of the side length, that's an adjacent. 5 is the opposite. Josh, you just said it was. Very good. So again, here we have to use two trig functions. Excuse me. So press some buttons here to see. The other one was tangent, wasn't it? Yeah. 207. That value of x is 2.07, which means that small section is 207, which means the other small section is 207, which means the whole segment is 140. So now you have enough information. It just looks messy. What you have now is we have a radius of 5.41 that needs to be squared. Slap a pi next to it, and then you subtract 1/2 8 sides of 4.14 times 5. It looks ugly. What you're doing, you found the area of the circle, and to that you have to subtract the area of the polygon. And instead of trying to piecemeal and put it all together and write them down separately, just put it all in at once and it works. 5.14 squared, slap a pi next to it. Subtract parentheses, 0.5 times 8 sides of 4.14 times an apothem of 5. I screwed up. 5.41. Yeah, squared, slap a pi next to it. Okay. Subtract parentheses. Oh, okay. 0.5 times 8 times 4.14 times apothem of 5. 915? You know, I can't hear you. I check. Oh, you can say the heading. I accidentally did 514 also. It's 541. The rest of it's fine. It's just this should have been 4. You did the exact same thing. You probably watched me do that. Okay. There you go. That's, I mean, quite honestly, guys, that's about as goofy as some of this stuff gets. It really is. Well, okay, maybe there's one other thing that'll happen. That's not going to work. Because you guys ever heard of a thing called probability? What's probability? Chance of something happening. So what's the probability you're going to get homework?
0.
It's 100%, isn't it? If it's 100%, it means it's going to happen. If it's 0, it means it's not going to happen. All right. Well, it's going to happen. So probabilities are always between 100% definite, 0 not going to happen. So if you flip a coin, what's the probability? That's heads. 50%. It's easy. It's either heads or tails. What's the probability if you roll a die and then you're going to get a 3? 1 out of 6. What's the probability if you roll a die that you're going to get an odd number? 3 out of 6, or it's 1/2. Okay. So as you get going, you start doing all this stuff. Well, there's this thing called geometric probability. What's the probability that I'm going to throw something and land in the shaded region? Well, what's the favorable region? If I want to land in the shaded region, what would be considered favorable? The shaded region, right? So what you're doing is, when you're talking about rolling a die, if I roll a die, the probability I'm going to roll a 3, the favorable thing is rolling a 3. Well, how many ways can you roll a 3? 1 out of how many possible? 6. 1 out of 6. Probability of landing in a shaded region means what's the area of the shaded region divided by the total area. Well, here we found the area of the shaded region. The area of the shaded region was 9.15 or something like that. Well, the largest shape here is what? Circle. So how do you find the area of a circle? Pi r squared. So what we would do is we would take that answer we just had, and I would just divide that by my 5.41 squared. I'm so bad with this calculator. You have to be careful, make sure you use parentheses here. This should work out a little bit less than that. Okay, yeah, I thought you said 9. I'm sorry. Yeah, so it's the probability that you would land in the shaded region here is 0.099. So that means it's, if you move it over, that's 1%. That's your decimal. So it would be what, 90%? 9.9%. So you have almost a 10% chance of throwing an object and hitting the net there. That's where dartboards come into play. That's why you have specific values on certain board games. The probability of rolling die. That's why as you're playing Monopoly, it gets more expensive as you're moving up. Because you get a greater chance as multiple. If you roll 2 die, what's the most common number you can get? Try again. 7s. When you roll 2 die, you have 36 total possibilities. Okay. You ever see this? So when you roll a die, really not what we're talking about today, but we'll get to this. When you roll a die, you can get. You should think craps, yeah. So I can draw this out nicely. So it's 1, so here's 1, 2, 3, 4, 5, 6. Sorry, it's not spaced out as evenly as it should be, but whatever. So when you roll 2 die, you can roll a 1 on one die and a 1 on the other. So you have a 1 and a 1, a 1 and a 2, a 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, and so on and so on and so on. When you roll 2 die, that's when you count how many spaces you're going to go. Well, the least common is rolling a 2 or rolling a 12. So now the most common, you get a 6 and a 1, a 5 and a 2, a 4 and a 3, a 3 and a 4, a 2 and a 5 and a 1 and a 6. The most common ones is rolling 7. So if you look at a Monopoly board or games of chance like that, you're going to see more error, more things that you have to pay on, would wind up being almost at multiples of 7s or 6s. Because if you look here, rolling a 6, you can either go, you can get a 6. I mean, if you're not looking at it in terms of order mattering, because it doesn't matter when you're counting, but you can get a 6 5 different ways, 5 and 1, and so on and so on. So that's why you get more jumbled up value at the more common. You get more value, more expensive towards the ends. That's how a lot of that stuff works. Gambling, isn't it fun? So here's what we want tonight. I'll give you a couple of these for now. Let's see here. On this one, let's do number, you'll do this on a separate sheet because obviously if you're looking at this, there's no room to do any of this work. Let's do 14, 15, 19, 20. 21 and 25. How's that sound? All right. Full whopping 6 of them. And I know that these take a couple minutes to do, so that's why I don't want to go too crazy. But that way, it was nice just to have them, that way you don't have to worry about opening a book or anything. But just do those problems. Do them on a separate sheet. Draw your 3 sides. Number 25 is the one that it's got the area. You'll find the area of the shaded region. So you have to do those 2 steps. But they're giving you a hexagon with a circle, so it's going to be fairly similar to what we just did with an octagon and a circle. All right.